So today we're talking about composition of functions. This symbol right here kind of looks like a little donut. It's read as f composed with g. So it's not the same thing as multiplication. You're not multiplying f and g, it's composing the functions. This is the real formal notation right here with the composition symbol. This is the way I much prefer that you write it. So if you see this formal notation, immediately change it to the less formal notation of f of g of x. We're composing functions with another function. It's kind of like, if you want to think about it this way, it's a function inside of another function. So first we evaluate the g of x function, and then we take the answer of that and plug that into substitute that into the f function. So it's kind of like evaluating a function twice. So let's look at a couple examples here. So given the function f of x is x squared and g of x is x plus 1, let's answer these questions here. So the first thing I want you to do is rewrite this in the proper form. So this would be f of g of 3. And so just like order of operations, we're going to work from the inside out. The inside function is g of 3. So the first thing you have to do is go, okay, what is g of 3? So we're going to take the g function. Everywhere there's an x, we're going to plug in a 3 there. And you could probably do this in your head. G of 3 is 3 plus 1, or in other words, 4. So g of 3, we can say that's really 4. So we substitute 3 into the g function. We get 3 plus 1 is 4. We're going to answer 4. So g of 3 is 4. That's now what we're plugging into the f function. So it's kind of like function notation twice. It's a function inside of another function. So now this gets plugged in wherever there's an x in the f function. So this would just be 4 squared, which is 16. So our answer is 16. The answer is f of g of 3. The answer is 16. So that's actually our answer. This is the name of it. It does not mean f times g times 3. It's f of g of 3. And the answer of that is 16. Now we're going to go backwards. So we're going to compose g with f. So let's see if that gives us the same answer or maybe a different answer. The first thing I want you to do is restate this in the informal way. So g of f of 3. We'll always want to evaluate the inside function first. So in this case, the inside function is f of 3. So in the f function, wherever there's an x, you're going to plug in 3. So that would be 3 squared, which is 9. So f of 3 is 9. Now we take that and plug it into the g function. So everywhere there's an x in the g function, we're going to plug in 9. 9 plus 1 is 10. And that's our answer. Again, that is equal to g of f of 3 is equal to 1 there. And now different functions here. So f is now defined as x squared minus 1. G is x plus 3. And so we're just going to plug this in one step at a time here. Again, the first step I would consider doing is rewriting this as f of g of 2. That's the informal notation here. First, plug in the inside function. So we're trying to figure out what is g of 2. G of 2 would be 2 plus 3, which is 5. Now we're going to plug 5 into the f function everywhere there's an x. So 5 squared is 25 minus 1 is 24. So this one equals 24. And this one we're going to go, this is g of f of 2. So function notation is not commutative with composition of functions. So we oftentimes don't get the same answer. It's possible to get the same answer. That has happened. But usually you get a different answer. So f of 2, so we're plugging 2 in there for x. 2 squared is 4 minus 1 is 3. And now once we evaluate the inside function, we're plugging that now into the g function. 3 plus 3 is 6. And so our answer for this one is 6. Again, we're allowed to change f and g from problem to problem. Could be other functions too. but these are the two most popular. F, G, and H are the most popular names for functions. Again, this is kind of weird because we're doing the g of -1. So again, the inside function is what you want to evaluate first, whatever that is. You want to figure out what what is g of -1. So everywhere there's an x here, we're going to plug in -1. -1 plus 2 is 1. And now we go back to the same function. Everywhere there's an x, we're now plugging in 1. 1 plus 2 is 3. So g of -1 is 3. So 3 is our answer there. And again, we'll do this one. So this would be f of, we have to evaluate what f of -1 is. -1 squared is +1. Plug that back into x squared, and we get 1. 1 is our answer on that one. Now we're going to compose with variables, and so this is something you can also do. This may not be obvious. Again, this is the formal notation. It just says f of composed with g. It doesn't say what number we're plugging in for x. So in this case, you basically just kind of understand that we're not plugging in a number, we're just plugging in x for x. So it's just f of g of x. So let's do the inside function first. What is g of x? So we're going to evaluate that first and then plug that in. So what is g of x? G of x is actually, if you plug in x, everywhere there's an x, plug in x, you get x plus 2. So this, another way to think about it, this is g of x. G of x is x plus 2. So I'm substituting that in there for g of x. Or you can think about it as that everywhere there's an x, I'm going to plug in an x. Again, you're going to have x in this answer here. Now, everywhere there's an x, with parentheses, I'm going to plug in x plus 2 into the f function. So instead of x squared, it's going to be x plus 2 squared. Of course, to solve this, that's a binomial squared. You're going to have to FOIL that. So you have to do x plus 2 times x plus 2, which ends up being x squared plus 4x plus 4. I'm not going to work that out, but I hope you know how to FOIL x plus 2 times x plus 2 there. Same thing here. This is going to be g of f of x. We're just plugging x into this function. So first you want to figure out what is f of x. F of x is x squared. So this is going to be g of, instead of f of x, I'm going to plug in this guy, which is x squared. Now everywhere there's an x in the g function, I'm plugging in an x squared. So this would just be x squared plus 2. And let's finish this out here. So this would just be g of x. Again, because it's not plugging a number in there. So we're just going to plug in the variable x and see what happens. So g of x would be x plus 2. So if you evaluate g of x, think of g of x. What is g of x? Well, g of x is x plus 2. So I'm going to plug in x plus 2. Now, everywhere there's an x in the g function, I'm going to plug in x plus 2. So right there, where there's an x, I'm going to plug in x plus 2. So it's going to be x plus 2 plus 2. So everywhere there's an x, I plugged in x plus 2. This, of course, simplifies to be x plus 2. And finally, f of x. So you're going to simplify the inside part first. F of x is really x squared. So this is going to be f of, instead of f of x, I'm plugging in x squared there. Now everywhere there's an x, I'm going to plug in x squared. So instead of x squared, which is where the x is, the new x is x squared. So that's plugged in there. And this simplifies to be x to the power u multiplies. So this would be x to the 4. So you plug in x, you usually are going to have an output of x as well. And that is your lesson.